Welcome to our exam review for Test 3. As always, with these exam reviews, I strongly encourage you to work out the answers first and then watch the solution guides to the individual questions. These, by the way, these questions are similar to the ones on the test. These are not the test questions, but they do review, in a general sense, the concepts that were covered in a similar manner to what the test is. So, as you're working these questions, just be aware that what you see is not going to match 100%, but will definitely feel very similar. So, on that note, let's jump in. Number one, consider the following statement: 85% of dentists surveyed own their own office. So within that sentence, we have a population and we have a sample. The population would be the idea of all dentists. Now, the sample in this case, they didn't actually go out and ask every single dentist if they own their office. They asked a very smaller set of that larger set. So the sample in this case were the actual dentists that were surveyed. Number two, identify the sampling method, whether it be simple random sampling, systematic convenience, or stratified. An advertiser wants to study an insurance ad's effectiveness. He randomly selects 15 male and 15 female participants in each age group to study. Okay, so in other words, the data represents a sorted group. They were first broken up into ages, and then they were broken up into gender. This is what's definitely referred to as a stratified sample. Second sentence, choose 3 winners of the door prize by randomly drawing tickets out of a bag. That is what makes a simple random sample simple. Number 3, for the following question, identify which type of statistical study, be it observational with case control, experiment, and experiment with single or double blinding, is most likely to lead to an answer, and then sort of give some sort of explanation with that. So the question that we are curious about investigating is, do guests at Walt Disney World weigh more than the average population? Okay, so the first task is to decide whether it's an observational study or some sort of experiment. I hope we don't want to subject people at Walt Disney to different types of eatings and then weigh them. So I hope we're not conducting experiments on them. So it is observational to start off with. Okay, and then the question then becomes, is it observational or observational with case controls? So you really have to think for a second. When we say case controls, what are we really, doing? And the fact that we are comparing I guess a subgroup of the population to the larger group. So we're looking at guests at Walt Disney World versus the average population. Well, that Walt Disney World group, that's a subgroup within the population group. And people that go to Walt Disney are considered people, right? So in that case, we would want to break this up into cases. We'd want to, in our sample, we'd want to separate the sample into groups at Walt Disney versus those that aren't, and then we'd be able to compare the average weights of some type with that. But so the idea of case control means that we are separating the data a little bit more than just collecting a bunch of numbers. We're going to put the numbers in this case, 2 different piles, one group that goes to Walt Disney World and one that does not. Okay. Now, as far as the explanation goes, I've kind of talked through a lot of good ideas that explain why this is observational. versus experiment. So one idea being that we are gathering data on things that we see versus forcing data to happen based on some sort of treatment or controls. And then as far as the case controls, we are separating the data. And number 4, a survey finds that 65% of Americans watched the Academy Awards with a margin of error of 3 percentage points. Construct a confidence interval from the survey results. So in other words, that 65%, that's just based on the sample, but based on the number of people they talk to, we can make a claim that while we don't necessarily think that 65% is the actual number, there's a range from low to high. So the low end is 65 minus the margin of error, and the high end is 65 plus the margin of error. So our actual confidence interval ranges from 62 to 68. So 62% up to 68% is how we notate the confidence level for that. Number 5, give an example of selection and bias and then explain your example. So selection bias, as it kind of sounds like, is when we get to select which experimental units are part of the study. So I guess an easy way to think about this is the lab. So a selection bias would be a lab experiment where the researcher gets to pick the subject. In other words, there's no blinding on the researcher's part. You know, it's kind of like if I make this awesome pet food and I get to, I grab 10 bunnies and I'm going to give 5 of the bunnies my pet food and 5 of the other bunnies the standard stuff. If I get to pick the 5 bunnies that I'm going to feed, well, of course I'm going to pick the biggest and strongest and let the weakest ones get the other stuff, and then I'll claim that, look, the strong bunnies were because of my food. So that would be where selection bias comes in. I get to pick, the researcher gets to pick which subjects actually are counted as part of the data. Number 6, in what way might the following study be flawed? A group of high school students are asked if they would oppose the repeal of the school policy that currently does not allow students to wear shorts in school. Okay, so hopefully as you're reading that, your first thought was, what? So if I say yes or no, what exactly am I saying yes or no to? So in this case, the flaw is the wording. They've overcomplicated the question in a manner that you're not quite sure what you're agreeing to if you say yes or no. So what exactly, for example, what does oppose the repeal mean? And so the complaint or the concern about this is there's way too many double negatives with this. So as a researcher or as just a guy off the street, if you ask me this stuff, I would just look at it and go, what now? Number 7, why do you think it's sometimes difficult to measure the variables of interest of a study? Give an example of a variable of interest that is difficult to measure. So variables of interest are when we are out there gathering data, I'm asking a question or I'm measuring something. The specific questions and the specific measurements would be our variables. So why would they be difficult to have to measure some of them? Well, sometimes it's just hard to measure things. So it's hard to measure some concepts. So for example, something numeric like a resting heart rate. Now I have a smartwatch, and my smartwatch will tell me what my resting heart rate is. My question is, are they resting like I'm sitting in a chair resting? Is it just when I'm asleep? What do you mean by resting? That needs to be a little bit better defined. If, for example, I want to take a study on whether or not each of us have found our true loves, our significant other, is that the one that we're meant to be with? When we say true love, what do you mean? So open to some interpretation. Talent, if I'm measuring that my talent is improved or that I have the best talent in my football team, what specifically are we measuring talent with, and what exactly does that word in and of itself mean? So variables of interest can be difficult to measure because sometimes they're just not defined that well. Use the following grades from a test in a math class to answer the following questions. So we're given this string of test grades, just A, B, C, D, and F. And then we're asked some questions about the data and specifically how to organize the data. So first question, is the above data qualitative or quantitative? Okay, and then why is that? Well, qualitative refers to the word quality or types of. Quantitative refers to the word quantity or numbers of. Since we're dealing with letter designations, we're dealing with a verbal description. Like I understand A students are better than B students, but I didn't numerically define it. We're looking at qualitative data. And this is because it defines verbal expressions or words. In our data. All right, next task, number 9, is to make a frequency distribution of the data. So first we need to define what our categories would be. So A, B, C, D, and F. Then I need to physically go into my data and count things. So let me count, start with A. So 1, 2, 3, 4, 5. So I have 5 of those. B's, I got 1, 2, 3, 4. 4 of those. C's, I got 1, 2, 3, 4, 5. D's, I got 1, 2, 3. 3 of those. And F's, 1, 2, 3, 4. So we got 4 of those. So frequency, again, refers to how often we make an observation of some type. Relative frequency, so relative means in comparison to, well, that means we need to think about, well, when I say 5, 5 out of what? So I just need to add them all up. Well, if I add up all of these numbers, so 5 plus 4 plus 5 plus 3 plus 4, I should get 21. So my relative frequency is going to be a fraction or decimal that represents each of the categories. So 5 over 21, 4 over 21, it's another 5, a 3, and a 4. And you can also type that in a calculator and get decimal approximations for each of these. Now either form is fine, be it decimal or fraction. What I find interesting is the number of students who are so worried about fractions, they'll actually find the fraction and then type it in the decimal and leave it in their answer in decimal form. And I'm like, you had to get a fraction to begin with. All right, and the number 10 is to create a bar graph with labels. So we're going to label A, B, C, D, and F. And it looks like the highest we ever get up to is 5. So 1, 2, 3, 4, 5. And then I'm just going to make a bar that represents each individual height. Now this is a bar graph, not a histogram, so the bars are not connected. as you're drawing this, I mean, try to make somewhat of a decent effort to make them look to be about the same height. I mean, I can tell when they're definitely different. You know, make the 3s and the 4s look different, I guess. Some of my 5s don't even look that straight, but oh well, it's not an art class.